All right. So chapter 4 is where we start getting into a lot of calculations. So this is where we'll start to actually find actual numbers. We're going to use the values. And we're going to start calculating actual statistics instead of just looking at graphs and more of the theoretical type stuff. So a few things when we're looking at data or and we're trying to summarize it, a few things we want to look for. So the first thing is location. So not where the data is actually located. It's going to be sitting in front of you. It's where's the center of the data. So does anybody remember back to elementary school and middle school and stuff like that? We were talking about you got a whole bunch of numbers and you had to do some calculations on it. What were some of the ways that you found the middle of it? Yes.
Is it the median or interest?
Median's one. Average, which is mean. So average and mean are the same thing. Median is another one. There's one more M. Yeah. Mode is the other M. Okay. We will also find range, but range isn't a location. So mean, median, and mode, those are your location data points. Those are trying to tell you where the center of the data is. Okay. They all do it differently, and they all are not going to give you the exact same center depending on how your data is formulated. The next one is dispersion. This is actually where range comes in. So range tells you large, smallest to largest, that type of thing. There's a few other different types of range that we're going to look at as well. In dispersion, you also are going to look at variance, how spread the data is. This is actually where what's known as standard deviation is going to come into play, which is one of the biggest parts of statistics and which is used quite often. The next thing we would look at is shape. So how's the data spread? Now, this is those curves that we were looking at. Like we had the bell curve, and then we had that skewed left and skewed right, correct? So that's where we're looking at the shape of the data. And then we can look at, along with the shape, is does it cluster? So is there several groups that are the mean? All right, is it bimodal or multimodal? So we can have, and mode is one of those ones that's the only one that we can have multiple ones of. Okay, so these are the things that we're going to look at and how to start summarizing data. So in this section, in chapter 4, we're really going to be focusing on what's known as descriptive statistics. We're summarizing quantitative data. Okay, so all the things I just mentioned are descriptive statistics. Depending on if we're looking at a population or a sample, we'll be either finding a parameter of the population or a statistic of the sample. And you guys we already talked about those two words back in chapter 1, where parameters were population and statistics were samples. So, but those pieces are descriptive. We're talking about the actual data points that are in and a specific calculation of it. What we're going to figure out going after chapter 4 and after you guys take this test and stuff like that is we're going to start taking this information and using it to make inferences. So we're going to look at sample data, and then we're going to use the information that we collect and calculate on it to infer what's happening with the general population. So the descriptive statistics is about what we're looking at specifically. And then if you take that and try to infer something about something else, then we move into what's in differential statistics. And that's when we get to the chapter 8s, 9s, 10s, those. That's when we're going to be doing that type of stuff. So right now we're going to be focusing on descriptive statistics. Okay. All right. Let's look at the first one. Mean. So I already said mean is the exact same thing as average. So how do we find average? Yeah. Yep. So almost all these are going to have a formula here. You don't necessarily need to write down the exact formula. It's not like an algebra class where you're looking at that exact formula and plugging things in. Okay. There will be some that we're going to do things like that, but this is not one of them. Average and mean are the exact same thing. Add all the numbers up, divide by how many you have. So don't get confused by all the X1s and X2s and stuff like that. It's just, those are all the data points that you have. So we're going to calculate the mean of this. So one of the things that, remember I said, confusing piece, is the English part of this. When it says calculate the sample mean or calculate the population mean, in mean, it doesn't actually change anything. But going forward, it will have some impact on some of the other formulas we do. So sample and population are two different things. Okay, so when you're looking at data, if it says it's sample data, that's looking at it as sample data. If it says it's population data, that means you have all of the data. Okay, so just keep that in mind when we're looking at it. Some of them will actually make a difference depending on what it says. So in this case, we've got a sample data of these 4 points right here, and we're looking at finding the mean of them. All right, so how did I find mean? So add them up. 4, 10, 7, and 50. All right. So when we're looking for the mean of these, what do we get? What do we get as our mean? I've now heard 2 different answers.
It's 36 divided by 4.
Yes, it's 36.
I do it all in my head. You grab a calculator.
Stop doing things in your head. Everybody has a calculator. So yes, you add them all up. So 4 plus 10 plus 7 plus 15 is 36. We divide by 4, which is 9. All right. So so we'll actually talk about this for a second now, because all right, so when you bought your textbook, you should have also gotten a code for Rugio or Rougarou, or however you pronounce this one. RGUROO. I do not know why they called it that. You should have also gotten a code for this. The nice thing about this program is it's going to do a ton of these calculations for you. Okay. So when we're looking at some of the more complicated formulas, especially when we start looking at standard deviation and things, those formulas are kind of complicated to do out by hand. So you are not going to want to do them by hand, especially if you're looking at a lot of data points. So all to do is when you register for this, you click student, create account, and you should have an access key. So just click access key, fill in the information, and it should register you. You do not need to sign up for a class or anything else. There's no class that is associated with it. Okay, so I don't have a specific thing that you have to put into code or anything else for that. Now, when you do that, when you sign in, you get a thing that looks like this. So it's going to come up as a screen. It's going to have a whole bunch of places where you can put data points. So I typed in the points that we had already here. We save, and then if you click this little button right here, it will do the basic calculations for you, and it will give you mean is one of the values it'll give you. So you can type your points in and it'll find your mean for you. Now this one was pretty simple. Should have been able to do it on a simple calculator. But notice it also gives you a ton of other data points that we're also going to be using to do calculations, including the standard deviation and the variance and stuff like that, that we'll be talking about a little bit later. So that was why you have access to this software, is because it'll allow you to do a lot of those calculations. The other nice thing is in your book, there's a whole bunch of data sets. They have access to all those data sets in here. So we'll actually be able to look at, like, here's Moneyball, like here's all the data points, and we can actually do calculations on data sets so you don't have to type the data in, to make our lives a little bit easier. So Sign up for Rougarou. If you have trouble with that, just send me a quick email and I'll walk you through it, make sure that we can get you signed up for it and everything else. You will be able to use this on your tests to do your calculations. So having it done before next Wednesday would probably be preferable, because then you can use it on your test next Wednesday, because there will be ones that you're going to have to find some of these calculations. And like I said, you have access to it anyway, so might as well use it. It also has built in the scientific calculator from Desmos, which is a really nice calculator. And we will use this to do some other things in there too, especially some formulas. I'll show you how to use this too to do that. So it's already built into that as well. So, all right. So we've got our mean. Very good. Now, not all means are as simple as adding up all the numbers and dividing by how many you have. Well, technically they are, but sometimes we have data that's not necessarily just a whole list of numbers that we have to add up. For example, if you wanted to figure out your GPA for college, it is not a straight just add up your grades and divide. It depends on how many credits that class is. So for example, this class is 3 credits. If you took calculus or pre-calculus, those classes are 4 credits. So if you got a B in a pre-calc class and an A in a statistics class, that B in the pre-calc class actually impacts your grade more than that A does in your statistics class, because it's more credits. These are what's known as weighted means. Okay, so like I said, unfortunately, it's not just add up all the numbers and divide. So the first thing in this problem we need to do is, I can't add B's. So we're going to change these to actual numbers. So based on the GPA scale, an A is a 4, a B is a 3, and a C is a 2. So a weighted mean, or means in general, can only be done with quantitative data. It has to be numerical. Okay. Because remember, quantitative data is the ones that we have the interval and the ratio. We can actually do calculations on it. If it's ordinal and nominal, I can't do calculations on them. So these won't work. So to do a weighted mean, we'd multiply that first. So what's 3 times 3? 4 times 4? 2 times 5? 4 times 3. Okay, how many do I have? If I add those up, what do I get? 47? Or 40? 18, 47. Okay. I was doing it in my head. I could have totally been wrong. All right, so I got 47. What am I dividing it by? How many numbers did I technically add? I didn't add 4. So that's the 4, right? Really, that 9 right there is 3 plus 3 plus 3, right? So that 9 is really 3 3s. That 16 is really 4 4s. That 10 is really 5 2s, right? So I'm not adding 4 numbers. I'm actually adding up the sum of these. So 7, 12, 15. So I'm actually adding up 15 numbers. So I would divide by 15. And I'm not doing that in my head. In this case, I get 3.1. Yes.
Are you using significant figures?
So, kind of. And significant figures is a science thing. Most of the time in your calculations, you want to go 1 decimal place more than what you have in the data. Okay. So in this case, that's why it's 3.13333 keeps going. Since all the credit hours are 1 decimal place, I would just go into just whole numbers. I went to 1 extra decimal place. However, if you're thinking about it in terms of general information in GPA. GPA is typically calculated at 2 decimal places. So it would actually be at 3.13. If you look at your GPA in your transcript, it's always 2 decimal places after it. So you don't need to worry necessarily about significant figures or significant digits. Look at it in terms of what they're either specifically asking you or what would make sense for that problem. So like money, if it's dollars and cents, I'm always going to go to 2 decimal places no matter what. It wouldn't make sense to go to 3 or 4, even if it's giving me the 2, because that doesn't have any impact on the actual data. In this case, your grade 3 wouldn't be as accurate as a 3.13 because technically you have a little bit higher of a grade than just a straight B. And we do have that continuous scale in there of GPAs. It's not just a 2, 3, 4. There's a 3.2 when you get cum laude, and then there's or honors or whatever else it is, and then there's different levels in there. So that's why you'd want to go at least 1 decimal place, if not 2. Normally the problems will tell you how many decimal places they want, especially in Hawks. So you won't have to necessarily worry about that. All right. Another place you use weighted average, not just with GPA, but is your actual grade calculations. If you're trying to figure out your grade in the class, you have to look at the weights of your tests, the weights of your homework and stuff like that. That's a weighted mean as well. It's still giving you that average of your actual class grade, and that would be considered a weighted mean. Does that make sense? Okay. Yes.
So what's with I think that's gamma, that gamma symbol or whatever.
That?
Yeah.
That's known as summation.
Okay.
So it's the sum of all the different points.
Oh, okay. Okay.
So yeah, that's just the summation. That's why I said, like, I would not focus completely on these equations, because especially the means, the concept you understand, the formula is probably going to cause you more trouble than understanding what you're doing.
So normal with math. So
Yeah.
pretty normal.
Yeah, and that's why, there's going to be most times there's going to be a few formulas that I'm going to have you guys use, but most of the time it's going to either be we're going to use a calculator to do the calculation for it, or it's going to be a simple formula that we can plug into the calculator and get the answer out. So you will not have to do very complicated formulas in this class.
So that symbol is the sum of all the numbers.
Exactly. That's exactly what that means. That's summation. Yes.
Will the homework assignments and have us have to figure out whether or not if they give us these values that we have to do this regular mean or the weighted, and so what would be the best way to decide to tell which way?
So typically, if they're asking you for just a mean, they're going to give you a list of numbers. If they're asking for a weighted mean, they're going to give you something and tell you what the weights are. It's got to give you extra information in there that shows you that. So like this, like I said, it's just literally a list of numbers, where this one, they're like, okay, here's a grade and here's a credit hours. Okay. And it'll say something like find the weighted mean or something like that. And it'll give you some clue on what you're supposed to be doing with it. So like this one, unless it says what's the average or the mean of the credit hours, it wouldn't make much sense. So. Any other questions on weighted mean? All right, we have one other type of mean we're going to look at. This mean is known as a trimmed mean. So look at these points, these data points right there. Okay. And they give you the mean for this one, right? What was the mean for this one? Right. Does that mean make sense?
Yes.
Okay. What's typically excuse me? What's typically a mean? When you're looking for a mean in most numbers, where does that mean typically fall at? Somewhere in the middle, right? That'd be what you would expect. Is 70.3 in the middle of all those numbers? What would you consider if I didn't give you a mean and I showed you the numbers and I just said guess what the mean is? You'd probably guess somewhere around like in the 30s, right? Because that's around in the middle of the numbers. However, in this data set, we have 490. 490 is considered a outlier. Okay. We're going to actually get an official definition of an outlier next class. But in general, an outlier is a number that's way out of whack compared to the rest of the numbers. Okay. So in this case, that number right there is pulling the mean to the right. Okay. It's pulling it away from the middle and pulling it more towards the right of that data. Does that make sense? Yes or no? Okay. So a trimmed mean basically cuts off the endpoints. Okay. By trimming off the endpoints, we can get a more accurate or mean of that data set that we have that isn't impacted by that outlier. All right. Yes. Oh, scratching it. That's okay. So this says a 10% trimmed mean. How many numbers do I have there? 10. What's 10% of 10? 1. So I have 10 numbers. I'm multiplying it by 0.10, which gives me 1. So I'm going to cross off one number on either side. Whenever you're doing a trimmed mean, you have to do the exact same thing to both sides. Because again, we're looking for the middle. If I wanted a 20% trimmed mean, that would have been 2 numbers, right? I have crossed off the 2 numbers at either end. Okay. All right. Now, find me the mean of those numbers. Did I script my numbers? Hold on. 18, 20, 21, 22, 23, 24, 32, 36. I think you might be a little low.
Yeah, I got 24.6.
Yeah.
Yeah.
24.6. Well, 24.625.
Yeah, 24 point. Yeah. All right. So this is where. So one of the things that I want you guys to start getting better at is what just happened here. When you get a number, look back and ask, does that number make sense? Okay. So when we got the original number, we had the original mean was 70.3. And we were looking at that and go, okay, I would have expected a mean different, but that 490 is really high. It probably made that make sense. When we're looking at trim mean, a 19 is going to be somewhere over here. There's nothing really to pull it this way. So that seemed a little low. Okay. So the better you get at understanding what those numbers mean and how they're used, the better you'll get at being able to catch if you made a mistake. And it is really easy to make a mistake with these, typing numbers into a calculator. It is really easy to miss a typing a 2 and put that in as a 3, for example. Like that can happen. So when you get a number on your calculator, I always ask that question, does this answer make sense? If it doesn't, go back and look what you typed in. Maybe you made a mistake. Maybe you didn't. Maybe it actually is the right answer and it just looks weird, which can happen too. So yeah, I used Rugio, got 24.6 for the average for this, or the mean for this one. So it's 24.625 exactly. Okay. So that trimmed mean can really take out those effects of those outliers that can have that impact on it. A great example of where this is used, if you ever watch the Olympics, is any kind of competition where they do scoring, like diving or gymnastics and things like that. They will always cut the highest and the lowest scores off from the judges. So actually in diving, they cut the top 2 and the bottom 2 scores off. So they have 7 people judging it, and only 3 of the scores actually count. They trim the top 2 and the lowest 2. It removes some of the bias. So sometimes somebody will give her just a really high score because of a variety of reasons. They might have screwed up, or they might like that country better. That used to happen a lot of times in ice skating and figure skating. So they would cut off the tops and the bottoms to eliminate those options. Okay, by taking care of the really low scores that would show up or the really high scores that would show up. So in that, they were doing. All right. Next one. Median. So median is a little different than mean. Median is the exact center, the middle value of the data set. So it is the center of the data set. Unlike mean, so like we're looking at this piece here, so that mean was a 70.3 because of that 490. If I'm looking for the middle number is going to be 23. That more accurately represents that information and that data than the 70.3 does. So median, the first thing you have to do whenever you're looking for the median is all the numbers have to be in order. Okay? They have to be put in order. If they're not in order, you cannot find the median. Then we have to figure out how many values there are and find the middle of the data set. If the value is odd, the median will be the number that's in the middle. So if you have 9 numbers, the middle number will be your median. If the number of data points is even, you will not have a middle number. So if you have 10 numbers, we actually have 2 numbers in the middle. You take those and find the mean or the average of those 2 numbers. You add them up and divide by 2. So no different than how you found median when you were in middle school, probably when you were looking at data. So for some of you, a long time ago, actually for most of you, a long time ago, at least 5 or 6 years ago. And I know at one point you were taught it because I helped write the lesson, the actual Common Core curriculum said when it was supposed to be taught. So, all right. Any questions on median? Okay. Find me the median of these data points. Yes.
86.5.
Okay. I haven't done it yet, so give me a second.
Oh, wait, yeah, reward them.
You do have to put them in order. If you did not put them in order. Okay, let's go back. What was the very first step? Range data in order. Very important step.
You gotta do
Mhm. All right, so our median for this one is 84. So your middle two numbers were 83 and 85. So 83 plus 85 divided by 2 is 84. Because I have 10 numbers, I have to add the two middle numbers and divide by 2. So your median will not necessarily always be a number that's in the data set. Sometimes it can be between two numbers. That is possible. All right, find me the mean of this one. Or median, sorry.
Is it 3?
Yes. So for middle number, yes.
Is there a tip in putting these things in?
Nope. Nope. I will tell you that. So, Ruguro or however that other website that we're using, it can give you the median without having to put them in order. So if you type the data points in, so you can see here. So here's those, or actually this was the other one that we did. Those are the 10 data points. And when I hit here, there was the median. So you don't necessarily have to put them in order for it. It'll do that for you. But no, there's no trick to putting them in order. And again, it's really easy to miss one. So yeah.
In a circumstance, in like a real world circumstance where you would have potentially millions.
Oh, you're not doing this by hand.
I was gonna say, like, how
So this is why, like, and there are teachers that I don't know here necessarily because I haven't actually seen the other teachers that teach this or statistics, but I've known teachers who require everything to be done up by hand or using a simple calculator to do the calculations, but for in essence, doing it all by hand. You are never, ever going to do this by hand. Okay? No, none of you. Even I would never do this by hand. Okay? Because typically we're not dealing with like 5 or 6 points. We're dealing with hundreds and thousands and possibly millions of data points. You're using a computer to do these calculations. Okay? So in that respect, use a computer to do the calculations. All right? Like make your life easier because that's exactly what you're going to have to do if you ever go out in the world and do this. Okay? So I have no problem with that because that's exactly what you're going to do in life. Yes.
It does.
Yes.
I had a math class last semester, and I just want to say that that was very real of you because she was making everything on the
Yes.
packet.
Yeah, you just don't. That doesn't the way it works. I understand some people are set in their ways, and there are certain things that understanding how to do by hand is very important to understanding what's going on behind the scenes. Like to understand that. So I understand there are certain things that you'd want to do that. But that was like the mean one, or like average. Like there's that formula that you can use, and I can show you how to plug all the numbers into the formula to figure it out, but you're not going to use it. As long as you understand what average is, that's the important piece. When we do standard deviation in a little bit, I am going to show you out by hand how to do it. I'm never going to expect you to do it, but I want you to show you it out by hand so you understand what it's doing, because that's important for that. But then you're going to use a calculator to figure out the answers. Yes.
In just one computer, everyone has to do it by hand, so like,
Mhm.
they have to like limit the amount of data they would have to. use.
Yeah. So if you notice, so that's actually one of the big things remember we were talking about, like the AI and stuff like that, large language models and the data and stuff. We've got so much more data today because we have computers that can calculate. When they were doing this stuff 100 years ago, when we didn't have computers, which amazingly, actually, computers have been around since the 1940s. So it's getting close to 100 years now. But before we had computers and actual like major calculators and stuff, yeah, most of the stuff was done by hand. And they were not doing millions of data points. They couldn't. So they had to limit what they were looking at. And that impacted. That's why once we got the computers and that technology, the pace of innovation is really accelerated because we have things to be able to do those calculations. So, yes.
I was gonna say too, the fact that, this level, the average level of statistics now, even this kind of stuff that we're dealing with, at least on a slightly higher level, didn't exist before that. I mean, they just
No.
winged it.
Yeah, exactly. It's like this stuff. Statistics is a relatively new field of mathematics. They did some basic stuff back then, but statistics is relatively new in the world of mathematics. Considering mathematics is like 3,000 years old, statistics is relatively new. All right, we got one more of these to do before we go on to some other stuff. This is the simplest one, mode. Mode is actually the only calculation that we're going to look at today that can be done on qualitative data. Okay, mode is just telling you which one appears most often. So in that data set, which one appears most often?
Are we supposed to see it or?
Oh, I didn't. Oh, I forgot. Sorry. Thank you. There you go. Which one appears most often? 0. If I eliminated that 0, which one now appears most often? Right. And 3. So in that case, now it's 0, 1, and 3 are my modes. So I have 3 modes. Modes is also the only one that you can have multiple answers for. Okay. Everyone that appears most often would show up there. Unless they all appear the exact same number of times. So if they all appear once, I have no mode. If they all appear twice, I have no mode. If they all appear twice except for one number, and that number only appeared once, every other number is a mode except for that one that appeared once. Okay, so mode is weird like that. And that's also why, notice I didn't do any calculations to determine this. That's why it can be done on colors, on sizes, things like that. That doesn't necessarily have to be a numerical answer. It can be qualitative data because I'm just counting. Okay? All right. We kind of talked about an outlier. An outlier is that one that's extremely different from it. Here's the wonderful little table of the types of measurements. Remember, I have qualitative and quantitative. So everything can be done in quantitative data that we talked about. Mode is the only one that can be done on anything. Median you can do on ordinal data because you put them in order. If once I put them in order, I could find something in the middle. So median can be done on ordinal data. But again, typically when you're looking at qualitative data, the only thing you're going to be looking for is mode. Outliers, the only one that is impacted by an outlier is mean or average. So that's the only one that actually has where the outliers can affect. That's where that trimmed mean comes into play. If we trim off those ends, we can eliminate some of the outliers and it's not as effective. Okay. We're going to look at outliers a lot more on Wednesday's class. All right. Here's my bell curve. In a properly set up bell curve, that is a perfect bell curve, the mean, the median, and the mode will all be directly in the center. Okay? If this was a histogram and I was stacking all those things up, the one that's tallest in the middle would be my mode, because that's the one that appears most often. And that's what a bell curve would basically be. That is also the middle of that curve, so that's the median. And if it's perfectly bell-shaped, the mean would also be there, because I have exactly, my average on both sides would balance out, because it's symmetrical. So in a perfect shaped bell curve, your mean, median, and mode are all the exact same value. Not everything is going to be a perfectly shaped bell curve, though. Okay. We have skews. We talked about it, was it last class or the class before? We had the right skew and the left skewed. And I told you I'd explain why. So this right here is a right skew, right? Because we're looking at the tails, correct? And this is left. Because again, we're looking at the tails. The reason why, look at the mean. The mean is being pulled to the right. And this one, the mean is being pulled to the left. That's why it's right skewed and left skewed. Because you're really telling where the mean and median are being pulled away from the middle, from that center line or the peak. And they're being pulled because of outliers, okay, or extreme points. All right. So in the standard bell curve, they're all stacked on top. It's left and right, depending on how they're actually being pulled away from that peak. So in this case, they're being pulled to the right. In this case, they're being pulled to the left. That's why it's right and left skewed. Another way to think about it is also as positively and negatively. Positives to the right, negatives to the left. Just remember back to your like narrow graphs and stuff like that. Your positive numbers are to the right of the graph, your negative numbers are to the left of the graph. So that holds true still. Okay. Does that make sense on why it's right and left skewed now? Yeah, I don't know why they talked about it in section 3 and then did this afterwards. It should have just been the same time. All right. So we started, so far we've talked, if we're looking at the thing I started at the very beginning, we've done location. Okay, so we've looked at location. We looked a little bit at shape, but we basically looked at location. That was the mean, median, and mode. Now we're going to look at dispersion. So dispersion is going to tell me how far I'm deviating or how spread the information is. So one way that we can do that is looking at how far away from the mean each data point is. So in this case, they're looking at deviations from the mean. They're just subtracting each of the points or the mean away from each of the points. So that 3 is -7 away from the mean of 10. That 12 is is 2 away from the mean. Does that make sense? So it's just one way to do it. This is not the way you're going to do it most often. But this is one way to think about it. It's how far away things are from the mean. And this is the beginning of how we would do standard deviation. We're going to start off with this, then we're going to do some other stuff with it. But we're really looking at how that data is spread. So we've got the middle, and then, okay, how far is stuff on either side of it? In a perfect bell curve, the stuff on either side of it would be exactly the same way apart from it. Okay, and I have an equal number on this side as I do on this side. The one dispersion value that you guys came up with was range. Range is just the difference between the largest and the smallest data points. So in this one, what's the range? You should put them on order, but you do not have to in this case, because you're really just looking for the smallest and the smallest and the highest. Yes. It is 23 because my largest is 24, my smallest is 1. So my range is 23. It's another way to think about how spread data is. We're looking at how it's spread out. So range will tell me that massive spread of what it's going to be. The smaller that range is going to be, the more compact the data is. The larger, the more spread it is. All right. Now we get into the complicated formula, which you're not going to have to do. I don't think. Okay, good. We're going to use that data point. All right. So you have two things that you're going to see quite often in the Hawks when you're talking about how much things are spread. The first one is known as variance. You do not need to know this formula over here. Okay? You do not need to know those formulas. You are going to use a computer to do this calculation for you. I'm going to show you what it does so you understand what it means. You are not going to need to know that. What you will need to know are those symbols. So the first one is population variance. So it's that little tiny O with the little tail on it. So that is variance. And just that is known as standard deviation. Okay. So for population, with the square is variance. Without the square, it's standard deviation. Remember I said that we're going to have different formulas for population and samples? This is where that different formulas comes into play. And it does change things, yes.
So the O with the square is population variance, and then without the square is
Population standard deviation.
Okay.
Yeah. Because the standard deviation is just the square root of the variance. Now, when you're talking about samples, it's just an S. So S squared is variance, and S is standard deviation. For a sample. And if you look at the formula, the only difference is in the very bottom. The first one was just divided by n. The sample was divided by n minus 1. So it does change it a little bit. So the symbols are what's important for you, and understanding the difference between population and sample. So if they ask you for a population variance, you're looking for that symbol. If you're looking for a sample variance, you're looking for the S. Okay. All right. Questions with that? Now I'll confuse you. Only for a minute, though. All right. So we've got these numbers. I'm going to put them in order so I don't have to deal with it multiple different ways. Okay. Can somebody find me the mean of these real quick? What's the mean? Nobody. Come on, it's just calculating. Fine, I do it. All right, so 8.5 is my mean. All right, so standard deviation in general is trying to figure out how far this stuff is varying, or how far it's spread, or the relationship between that and mean. First thing we want to figure out is, as actually we did at the beginning, it's the deviation from the mean. So how far are each of these away from the mean? So I'm going to subtract the 8.5 from every value. So I get 2.5? No, 3.5. 5. Okay. So signs kind of matter. If we're looking at, don't worry, all this stuff will be back when you do your actual notes. All right. So in essence, what I just did was this piece in here. I did my number minus the mean. Next thing I got to do is square them all. So I'm going to square them.
You're squaring each one.
Yep. Now you're going to know why I told you you're not going to have to do this up by hand, because as you can tell, it's a lot of steps. So I've now squared them all. Well, what did that symbol in the front mean? What did I tell you before that? Yep. I'm now going to add them all up. Oh, wrong way. And I get 29.5. And then the last step, I'm dividing them by how many I have. So I'm going to divide that number by 6. And I get 4.92. So this is sample. So this would be S squared equals 4.92. So did I do that wrong?
Yeah, the 11 shouldn't be, that shouldn't be 3.5, that should be 2.5. 11 minus 8.
Oh, you're right. It's 2.5. Is that one 3.5 or is that one 2.5?
5 minus 8.5 is negative 3.5.
Okay. All right. Start over. I'm just kidding. So 23.5 is 3.92. Okay. So that's my variance of the sample. If I wanted to find my standard deviation, so just the S, I just take the square root of 3.92. And that gives me 1.98. So this is variance. And this is standard deviation. what is it? 5, 10, 9, 11, 5, 10, 9, 11, 9, 7. All right. So I just put those numbers right in here, right? There's the numbers. If I hit that little calculation thing there, oh, somebody want to tell me what I did wrong? We'll see really who was actually really paying attention. What did I divide it by?
Oh, you have to do it by everyone else, right?
I have to divide it by one less
Oh.
because it's simple, which is n minus 1. So I should have divided this by 5, not 6. I'm like, wait, why didn't my answer come out right? So 4.7 and 2.17. Okay. So now if we go back and look at this, you'll see oh, too big. Right there, my standard deviation, 2.16, my variance is 4.7. Okay? That's how you're going to do it. The only reason I ever show it out by hand is if I just told you the standard deviation is 2.17, you go, huh? Because that really has no relationship to the numbers. Okay? Unlike mean, median, and mode, like those have a direct relationship to the numbers. 2.17, even 4.7 doesn't have any really direct relationship to the numbers. What it's telling you is how far that information is spread out. Okay? So if we're looking at the mean, which is 8.5, if we go out 2 from either direction, we can start to get information. It's like, okay, now we're starting to get more and more of the actual data. That's what the standard deviation does. That's why when we started it, we literally subtracted it from the mean to start. Okay? Because it's really trying to tell me how far away from the mean I am. All right? Okay. Couple very important things about standard deviation. Standard deviation can never be negative. Okay? It'll always be positive. Because let's think about this for a second. Variance is squared, and squares can never be negative. And I can't take the square root of a negative number. So therefore, it's got to always be positive. It could possibly be 0, but that's only if every point is the exact same. So if I gave you 100 numbers and they were all 5, the standard deviation is 0. Because they're all the exact same number. If you have outliers in the data, standard deviation can get big, quick. Because remember, in essence, standard deviation is taking it away from the mean. So if I had my mean as being 8.5 and I had a number that was 1,000 in there, subtract that, that's going to make a really big number. Now going through the steps, that big number is still going to impact my answer. So that's where standard deviation is talking about that variance, how much things varied from the middle. So if you have a number that's way out there, you would expect a big standard deviation because it's going to be spread a lot more. And you want to express it in the same units as the original information. So if we're talking about money, it's in terms of money and those type of things there. So, but the big ones is it can never be negative, and they can get big really quickly. All right. And actually skip that. We'll talk about that later. Population data. So there is what's known as a coefficient of variance. A coefficient of variance. Hold on. That's what I want. A coefficient of variance allows us to be able to compare our standard deviation and the variance between different pieces of information or different data points or sets. So the coefficient of variance takes our standard deviation divided by the mean times 100. So in the last problem, my standard deviation was 2.17 and my mean was 8.5. This formula you have to do out. So it's 2.17 divided by 8.5 times 100. And this formula is simple enough that you can do it now. And we get 25.53%. So that's my coefficient of variance. Yes.
What is the U symbol? What does that mean?
So this is for population. That's the mean symbol for population.
That's in the population.
Yes, for mean.
Oh, mean population.
Yes, that is mean. That is also mean.
They're both mean.
Yes, they're both mean.
Okay.
It's just the mu symbol is for population. The X with the bar over it is for sample. Same thing with the standard deviation, how it changes. So typically for population, we use the Greek letters. And for sample data, we use yeah. So, okay.
And then for everything else we use Arabic.
After that one, that's the one I want to delete. Okay. So let's do one problem with coefficient of variance, and then we're done for today. So a consumer group is interested in a company comparing two brands of vitamin C. One brand of vitamin C advertises its tablets contain 500 milligrams of vitamin C. The other one says it contains 250 milligrams of vitamin C. For each tablet, brands are randomly selected and the milligrams for each were measured. So we've got 500 milligrams is the mean with a standard deviation of 10. And for brand B, I have 250 milligrams as the mean with a standard deviation of 7. So remember that when you buy anything, okay, if you buy vitamins or anything else and it says it's got 100 milligrams of something in it, every pill is not exactly the same. There is always a little variation in how much is in. Okay. How much of a variation is the key. And that's really going to depend on that part. So in this one, they've got a variation of 10 milligrams. This one's got a variation of 7 milligrams for its standard deviation. So what's my CV of brand A? So what would I do? Yep. Times 100, which gives me what? Yes.
Percent.
Yes.
Yeah.
That's why you're multiplying it by 100. You're just changing it to a percent. So you technically don't need to multiply it by 100. You can just move the decimal 2 places. So I have 2% is my coefficient of variance for brand A. So what's brand B's? What was it? Right, which is what percent? 2.8%. So which one's more consistent? A is more consistent, the smaller percentage. Because I'd want that number to be, if it was perfect, right? If all the polls were the same, my standard deviation would be 0, correct? That was what I said. If all the numbers were exactly the same, standard deviation would be 0. So if I did 0 divided by 500, I'd have 0%. That'd be perfect. So in this case, you're looking, the smaller the number, the better it is. So brand A would be better in this case with 2%. Okay? Told you. More calculations this class. And we're going to do more next class too. So I would highly suggest getting signed up. Make sure you can log into that site. Will help you do your calculations. You should be able to do the homework for 4.1 and 4.2 now. I would highly suggest if you're behind trying to catch up at this point, because all that stuff's going to be on the test next week. It will skew quite a bit more towards chapter 4 than 1 through 3, but there will be stuff from 1 through 3 on there. I will see you on Wednesday.